Okay, so right now we're tackling this question, which is ACMNA214. So we're trying to find the distance between 2 points located on a Cartesian plane using a range of strategies, including graphing software. So we've got a bit of a set of axes here. You know, we might want to label this as our x-axis, and this is our y-axis. And then say we've got 2 points. Let's pick this point here and this point here. Actually, I'll do them in different colors. This point here. So our first point is 2 across and 3 up. So we're gonna call that point. I'll call it point A. Point A is 2 across and 3 up. 2 in the x-axis, 3 in the y-axis. And then our point B is 1 across and 1, 2 up. So there are 2 coordinates. We need to find the distance. Well, our distance is going to be this length here, isn't it? So I might call that h. Now the question is, how do we work out h? Well, one thing to work out that's easy is to work out how far it is from B to here, right? So we could call this C. So we can say B to C is equivalent to 1 step. One step. And that's just the same as the difference between 2 minus 1. 2 minus 1. And then C to A is the same as just 3 minus 2, which is 1. So now here we have to remember something important, and that's the fact that, first off, if we recognize we can represent this as a triangle, then we can use Pythagoras' theorem. And that says that hypotenuse squared is the same as side 1 squared plus side 2 squared. Right? So that's what we're dealing with. Hypotenuse squared, which is this one, is the same as side 1 squared plus side 2 squared. Okay, which means that, therefore, I can use the therefore sign, hypotenuse squared equals, well, side 1, well, that's just B to C, isn't it? So we'll call that. And this one's side 2. So that means side 1 squared is just 1 squared plus side 2 squared, 1 squared. Therefore, hypotenuse squared equals 1 plus 1. Hypotenuse squared equals 2. But we don't want hypotenuse squared, do we? We just want hypotenuse, this h here. So what do we have to do to both sides to get just h by itself? I'll write this out again as h squared equals 2. Well, what we have to do is square root both sides. Right? And so when we square root both sides, when we square root h squared, we'll start here, square root h squared equals square root of 2. Right? Therefore, I'll go from there to there. Actually, I won't do that. Therefore, well, when we take the square root of a squared number, for example, square root of 2 squared is the same as square root of 4, and that's just square root of 2. So we recognize this pattern. When we take the square root of a squared number, we just end up with, equals 2. When we take the square root of a squared number, we just end up with that number itself. So if we take the square root of h, the square root of h squared, we just end up with h equals square root of 2. So we know that this equals the square root of 2. So we've answered the distance between the 2 points, A and B, is the square root of 2. Let's think of another example. I'll just do this. Clear ourselves some space. Okay, let's think of another example. Maybe we'll take a point here and a point here, and we'll call this point M now, and point N. So point M is at 3 across, 3 in the x-axis, and 1 up. And point N is at 1, 2, negative 2, and 1, 2, negative 2. So now we have to say, okay, we'll call our distance the hypotenuse again. And an important thing I should have mentioned before is that Pythagoras' law only works for right-angled triangles, so that was a right-angled triangle. Now we can kind of see where we're going here, so I'll just put the triangle in to start off with. Again, right-angled triangle, and I call this H. And again, I'll call this side 1 and side 2. Oops. Side 2. So now, I could say side 2. I'll start with side 1. Side 1 equals the difference in the y's, and the difference in the y's here is just these two numbers. So that's 1 minus negative 2 equals, well, 1 minus negative 2 is the same as 1 plus 2 equals 3. And then for S2, we just need to look at the difference in the x's, which is 3 minus negative 2. So we're taking M and we're taking away point N. And I should note that we could do this either way. We just get a negative answer. So 3 minus negative 2 is the same as 3 plus 2 equals 5. Let's try it the other way. If we went negative 2 minus 3, we'd have negative 5. And we'd be thinking about going that way instead of that way. But if we take away the bottom left point from the top right point, then we should be pretty safe. Okay, so Pythagoras' theorem, Pythag, we know that hypotenuse, I won't call it hypotenuse this time, I'll just call it h squared equals side 1 squared plus side 2 squared. Therefore, h squared equals side 1 was 3, so we need to square that, plus side 2 was 5, so we need to square that. Therefore, h squared equals 9, 3 squared plus 25. Therefore, h squared equals, well, we've got almost 25 plus almost 10, so that's just, but it's 1 less than that, so it's 34. And so what we need to do here is say, okay, square root both sides, square root both sides, and again we end up with, therefore, h equals the square root of 34. Now that's not a nice square number, so we'll just leave it at that. But there's two examples of how we can find the distance between 2 points located on a Cartesian plane. We haven't used graphing software, but this is pretty much the fundamental. Just working out that distance, using Pythagoras' theorem, and then the other key point, which was square root both sides when you want to get down to h by itself. So this h equals square root of 34. Hope that helped.